Hi, everybody. We're going to be doing Q11, which is find the inverse of a function. This is an extremely important section in functions, and there's a bunch of conceptual ideas that I'm going to go through. At first, I'm just going to show you how to do it, and knowing how to do it is important. But the underlying conceptual is extremely important, partly because algebra, the basis of algebra, especially solving, for example, is to do the opposite. And doing the opposite is literally the definition of inverses. So I hope you'll stick around for some of the explanation as to why you're doing what you're doing. But at first, I'm just going to stick with the how, okay? So we're going to find the inverse of a function. I haven't previewed it, so it's going to be a bit of a surprise, just as I thought. Write your answer in the form of ax plus b. So one way to think of inverse is that if you think of a function as being an x and a y pairing, um, this would be a function, and its inverse would be y gives you x. And one way to think of this is that if you have a function like x minus 5, y equals x minus 5, you are given x's like 0 and 1 and 2, and they are giving you y values like -5, -4, and -3. And this direction is the function, and we're used to doing this. This is called a mapping. Now, the inverse is to do the opposite of that, which is start with y and go to x, doing the literal opposite. So now in order to do that, notice what happened here. The xy got reversed, didn't it? The y is now the x and the x is now the y. So that's what I'm going to do. I am going to switch the x and the y. So I have x equals y minus 5. But we want to write it as y equals. So in order to do that, we're going to add 5 to both sides. Now, the problem with doing this is that this is no longer really y. It's a different kind of y. It's the inverse of it. So what I like to do is when I do that switch, I put a little mark on it. Now, one way to put that is you could call it the -1 of y. The problem is that mathematically, y to the -1 already has a definition, and it looks like this. So my recommendation is to just put a little mark next to it and call it like y prime. That also has a definition in mathematics, but by the time you get to that, you won't get confused with the inverse. Anyway, so my new equation, which is the inverse, is x plus 5. Now think about that for a second. What happens when you take -5, and which was right there, sorry, it's a little messy, and you add 5 to it, don't you get 0? And take the -4 and you add 5 to it, you get 1. It's going backwards. So there it is. That's a lot of explanation, probably more than you bargained for. Sorry. Alrighty then. Now the inverse, I'm going to switch the x and the y. So I'm going to write x is equal to -5 times my inverse. And I'm going to divide by -5 on both sides. So I get y prime, or the inverse, is x over -5, or -x over 5, or -1/5 x. There's lots of ways of writing this. They want it as ax plus b, so I probably should write the -1/5 x. I'm thinking that that's going to be the best. Oh, there's my fraction bar. I think I'm going to go ahead and use it. Now, you probably could get away with not using it, but I think it's a good idea because the x is really up here, isn't it? Not in the bottom. And let me erase this so you can see it a little better. There's what it looks like, -1/5 x. And this one is going to be -1/4 x, isn't it? Because I'm going to switch the x and the y. I know you're probably thinking that you could simplify this down and you don't have to go through all these steps, but I'd recommend that you do it anyway because it's good practice to understand what's really happening. I'm going to divide by -4 on both sides, and we are going to get y prime, the inverse of y is equal to negative 1/4 x. Okay, I know you can figure this out in your head, but I'm going to write it anyway. It's x equals the inverse minus 7, and I'm going to add 7 to both sides. I'm doing the opposite. This one is going to be x plus 3, isn't it? But I'm still going to switch it. Add 3 to both sides. Maybe it'll make a difference later. I'm going to do the opposite. You know what? I think I'm just going to put the x plus 4. I think you've seen it enough so that you understand that when it gets to a more complicated one, maybe we'll switch it. There we go. Okay, so now I've got, since y equals negative 3x plus 2, again, I got to tell you, if you're going to switch your x and your y, you really need to give that new y a different name. So x is equal to negative 3y plus 2. I'm going to end up subtracting 2 from both sides. And that's going to give me x minus 2 is equal to negative 3 y prime. And now I'm going to divide by my negative 3. And you need to be a little bit careful here because that negative 3 really is under both of these. In other words, when I divide by negative 3, this is a common denominator. And I end up with negative 1/3 x, and then I have a plus 2/3. It is really easy to mess that up, especially if this had been, if this 2 had been a 6 or something that would cancel with the 3, you're going to be tempted to do that. So as I said in earlier videos, you do want to separate out that common denominator. So we're talking about y equals negative 1/3 x plus 2/3. Now, a lot of people say, well, why don't you put a decimal? I like decimals better. And watch this. And even worse, it's only approximately equal, isn't it? You don't want to do decimals. Nah, I like fractions. I know you don't, but there you have it. 1/3, and we're talking about x plus 2/3. Now there's my neat work when I'm substituting in. You could, of course, use the slashed fractions. It's just that they're not as safe, especially when you guys start getting into reciprocal things in the next section. Looks like that's it. So let's do another one. Oh, x minus 1. X minus 7. Maybe we'll get another tough one. Let's see. Not really. 1/4 x. Oh, they rewrote it as a different notation. Now I like that. A function y equals 4x, remember, is the same as f of x equals 4x. There is absolutely no difference between y and f of x. And this f inverse of x looks really funky. Remember, that's the same as our y prime that we've been using. Well, this is so weird looking, and it's so complicated looking that I prefer to use this one right here. So I usually rewrite it like this and then switch my x and y. It just makes it easier. So I've got, let's write x equals 4y prime. And of course, we're going to divide by our 4 on both sides. So it's x over 4 or 1/4 x. So f inverse of x is 1/4 x. I probably can get away with doing it this way, I'm going to guess. Yeah, I didn't think I had to use the fraction bar if I didn't want to. All right, x minus 1 gives us x plus 1, of course, when we want the inverse. The opposite of adding 3 is subtracting 3. Darn, I was hoping for a hard one. X plus 2, the opposite of subtracting 2 is adding 2. X plus 6. If I had missed the one where it gave me the extra multiplication, then it probably would have given me more of those. I probably should have missed it once. Anyway, I hope you guys will try it yourselves, and I'll see you back. Bye.